Yes, ma'am.
Any problem, Abdullah, so far?
No, ma'am.
Okay, so here is question number 8. As you now, what does it say? So using theorem 6.2, okay, of class, sorry, theorem 6.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So this is reciprocal of the midpoint theorem. So let me just revise. In question number 7, what we did, so there was a triangle, right? So let us have a comparison between question number 7 and 8 first of all. Don't write, just pay attention. Okay. So in question number 7, what happened is, for example, this is triangle ABC. This is also, let me call it ABC. So what was given here? It was given that D is the midpoint of AB, right? And it was also given that this line, so D is midpoint, right? And also it was given that DE is parallel to BC, correct? And what we have to prove? We have to prove that E is the midpoint of AC. Understood? This was question number 7. Now in question number 8, it is just the converse. So it is given, prove that the line joining the midpoints of any two sides of a triangle. So D is already a midpoint and E is already a midpoint. So now just look what is given. So D is the midpoint, right, of AB, and E is the midpoint of AC. Now this time what you have to prove is, you have to prove that DE is parallel to BC. Understood? So that is the difference here, right?
Yeah.
So this thing was already given in question number 7, and you have to show that E is the midpoint. Now this time E is the midpoint. This is already given, and you have to show that the line DE is parallel to BC. Is that understood, everyone?
Yeah.
Okay, so let us see how we
Yeah.
can do it. Right. Uh, just scroll it down for you. Sorry, it's not scrolling down. Anyway. So let us start this question number 8. So let us write down first of all what is given to us. Let us draw a triangle for it. So it's a triangle A, B, C, and there's a line here, D, E. Right, so it is given that D is the midpoint of AB and E is the midpoint of AC, right? And you have to prove that DE is parallel to BC. So let us show it. Now it is given that in triangle ABC, right? So we are given that AD is equal to DB, right? So can I just write it like this? AD upon DB is equal to 1, fine, right?
Yeah.
I'm just bringing this DB in the denominator. So on the right hand side, I'm getting 1. So let me call it equation number 1. Similarly, it is also given or before this, you can write that D is the midpoint of AB, right? Therefore, AD is equal to TP. Similarly, E is the midpoint of AC, right? So we can write, therefore, AE is equal to EC, right? And I can write it AE upon EC is equal to 1, right? Mark it equation number 2, right? Now,
Yes, ma'am.
in equation number 1 and 2, you can see right hand side is 1, right hand side is 1. That means the left hand side is also equal, right? So from 1 and 2, what we can say is, we can say that AD upon DB is equal to AE upon EC. So if I just draw it again here, so this is A, B, C, and D, E, right? So I got AD upon DB is equal to AE upon EC, right? So here I can use basic proportionality theorem.
Ma'am, I have a question. Like, when
Yeah,
you
sure.
put the other side, how does it equal to 1?
Okay. Let me just complete the question, then I'll go back to that. Okay. So from 1 and 2, now see here, I have got this part upon this part is equal to this part upon this part, right? So we can say from BPT, what we can say is that the line DE is parallel to BC, right?
Yeah.
So basically, we have to make use of basic proportionality theorem to prove this. It is also mentioned in the question that use theorem 6.2. Okay. So we have proved it. Okay, now your question. Basically, sorry, it's not BPT. It's actually converse of BPT we are using, right? Sorry. Yes, Martin, I'm just explaining. Wait a minute. Okay, Arshia, any problem here? Okay, who else is there in the class? Okay, Arshia, please unmute your mic.
Yes, ma'am.
Any problem?
No, ma'am.
Okay, Subhana, any problem? Mana, any problem here?
How did we get this one?
Yeah, okay, I'm just explaining that. Okay, wait. So far, is it clear from converse of BPT, right? Okay, so how I got it one? Let me explain it here. So I have AE is equal to EC, right? I am just bringing, okay, just try to understand it this way. Can I just write it AE is equal to EC multiplied by 1, right? Then I can bring this EC in the denominator, right? So it will become AE upon EC, and here I get only 1, isn't it?
Yes.
Yes?
Yeah, ma'am.
Okay. Or you can also understand it this way. I have AE is equal to EC, right? So on the right hand side, I want 1. So I can divide both sides by EC, right?
Yes.
Divide both sides by EC. Simply, I'll get AE upon EC is equal to EC upon EC, that is 1. Right, Martin?
Yeah.
Okay.
Oh, okay.
Like any, it depends, like whichever way you want to
Or like,
understand
why
it.
isn't it like 0?
0. No, no, Martin, see, now see here. It is simply EC. So I can write it EC into 1. I cannot write it EC into 0. Otherwise, the right EC will not exist here. I'll get AE is equal to 0, isn't it?
Yeah.
Yeah. So if there is nothing, I can multiply the number by 1. So there
Okay.
is no change in the number. So I just assume that
Okay.
it is multiplied with 1. So I just leave the 1 here and I take EC in the denominator.
All right.
Okay. Or you can understand it this way also, that I just simply divide both sides by EC. That's it. So your EC by EC becomes 1. Right?
Yes.
Okay. So I hope this you have understood how I got 1. Yes, Abdullah?
Yes, ma'am.
Okay. And here in the last step, see why this is converse of BPT. So again, I'm just going back. If this is a triangle ABC, right? And you have DE. So according to BPT, so it is given that DE is parallel to BC, right? And what is the result? The result is that AD upon DB is equal to AE upon EC. Remember all of you? And then converse. If I say converse of BPT, now what is given? It is given that AD by DB is equal to AE by EC, right? And what is the result? Result is that DE is parallel to BC. So basically here I got this thing as my, so basically this is given. So therefore I'm saying that from converse of BPT, DE is parallel to BC. I hope this is clear.
Yeah.
Okay. Next question. Mana, I can't hear you today.
Yes, ma'am.
Yeah. Any problem so far?
No, ma'am.
Yes, Subhana, are you there? All right. ABC is a trapezium in which AB is parallel to DC, right? So you have a trapezium. It looks like this. So two sides are parallel in a trapezium. So AB is parallel to DC. So I can call this one AB and this is DC, right? And its diagonals intersect each other at point O. So these are the diagonals. And this point is O. So you have to show this thing. Okay, so let us write down what is given here. It is given that ABCD is a trapezium, right? Or you can say that AB is parallel to CD. I mean, when we write it is a trapezium, so it means that any two sides are parallel and the other two sides are non-parallel. Okay. You have to show that AO upon BO is equal to CO upon DO. So everybody look in the figure, where is AO and where is BO, right? Okay.
Okay.
Hmm. See, because I want to use BPT, now try to understand one thing here, because I want to use BPT, right? So in BPT, for example, this is a triangle. So ultimately I need a parallel line, isn't it? If I want to use a BPT,
Yeah.
right? But you can see there is no parallel line here. I mean, there's a triangle. As you can see, this is a triangle here, right? But in this triangle, there is no parallel line in between. So we have to do a construction, okay? Now, what is the construction here? So we will draw a line which is parallel here, and I call it E, right? And we draw it parallel to DC, okay?
O even DC.
Yeah, so draw EO parallel to DC. Is it okay? Yes, okay.
Yeah.
Let us do the proof now. So now I got a parallel line here, so I can like think of using BPT this time, okay? Now for BPT, oh wait. First of all, we need to show, see, we have drawn EO only parallel to DC, right? But we also want to show that
Yeah.
EO is parallel to AB also, right? Only one line we use in the construction, that is DC. But I want to show that EO is also parallel to AB. Now, how will I show it? If you go back to class 9th, right? So there was a theorem. What was the theorem? That, for example, the theorem was this. Like you have three lines, right? If this is your line L, this is M, and this is N, right? So everybody pay attention. So the theorem was that if L is parallel to M, right? And also L is parallel to N. So what we can conclude? We can conclude that the line M is also parallel to N,
Oh, LH and RH.
right? So the lines which are parallel to the same line. So M is also parallel to L, N is also parallel to L. That means they are parallel to each other as well. Understood?
Yeah.
Okay, so we are going to use this theorem here. So we have drawn that EO is, or you write like this, that DC is parallel to EO. How? By construction, right? Okay. And DC is also parallel to AB. This thing is given, right? Because it's a trapezium. So we can conclude that EO is also parallel to AB, right?
Yeah.
Okay. Now, because EO is parallel to AB now, okay? EO is parallel to AB. So if I want to use BPT, so can I write that, how will I write it? So if EO is parallel to AB, so I can write, just look at it like this is the base this time, right? So I will write that DE upon EA, right, is equal to
AO upon OC.
DE. So OD upon OB, right? Or
Yeah.
I should use this term, like in the proof it is written DO. So instead of OD, I should write DO, right? So you don't get confused. So BO, correct?
Yeah.
Okay. Is this understood, everyone?
Yes, ma'am.
Yeah.
Yeah. So
Yes.
now because these two blue lines are parallel, that means this part upon this part is equal to this part upon this part. How? From PPT. Right. So you just give this equation some number. Let me call it my equation number 1. Sorry, before this you need to mention the triangle also. So just a minute. Before writing this step, we should write which triangle we are considering, right? It is important. So far is this clear? Okay, EO is parallel to AB, that we have proved. So we choose a triangle. So in triangle DAB, then we write. So now EO is parallel to AB, and therefore DE upon EA is equal to DO upon BO. Clear? Now you can call it 1 by BPT. Is this understood?
Yeah.
See, it's important like which triangle you are considering. So first of all, choose a triangle and then proceed. Okay. Now again, I want to choose a triangle. This time I'm going to take the red triangle, as you can see. Right? So previously I took this triangle, the blue one, right?
Yes.
DAB. Now I'm going to choose ADC. Clear? The red one in the figure. Okay. So now in triangle ADC, can everybody see ADC? Yeah, this red triangle ADC. Okay. So in this triangle, EO is already parallel to DC, right? By construction. This is by construction. So we can use BPT here, right? So again, I can write AE, AE or EA, okay, AE upon ED, right? Is equal to, what will I write now this time? AE upon ED. So I
AO
should write,
upon OC.
yeah, AO upon CO. So use the same like Instead of OC, I'm writing CO, no problem, right? Okay. Now, can you just compare 1 and 2? Now here I have DE in the numerator, right? And I'm having here in the denominator. So I can just flip this equation. Any problem?
No problem.
Yeah. So, or we can just flip it. So I'm just bringing ED, or can I write DE or leave
Yeah, we
it?
can write D.
Okay, leave it, write it ED, otherwise it will get confused. So I'm just flipping it. So I'm taking denominator into numerator and numerator into denominator, right? Okay. Now, can you just compare 1 and 2? So this is DE, this is DE. See,
Yeah.
ED and DE, same thing, right? And EA
So
and
the CO upon A equal to D of V.
so, yeah, so left hand side is same, right? So from 1 and 2, 1 and 2, now I get DO upon BO is equal to CO upon AO. Now you see what we have to prove. We have to prove AO upon BO. No problem. So you can do cross multiplication, right? You can take this AO this side. So I'm taking AO upon BO, right? And this is CO and I'm bringing this DO here. So I got my result.
Now, how can we do that? Can we just directly do that or like is there any
Okay, there are steps. Yeah, we can directly do it, but if you want to understand, I can explain it stepwise, no problem.
Yeah, all right.
Yeah, just wait. So you have this result, right? So can I
Yeah.
just take one at a time? It is already DO. I'm just taking this AO here, right? So I have CO divided by 1 only, right? When I take something, so 1 is left, right?
Okay.
Yes. And in the next step, I can bring this number in the denominator. Is there any problem? So I just, yeah, if you have, for example, you have 4 into x divided by 3 is equal to, let's say 2. So can't you bring this 4 here in the denominator, right? Yes, Martin?
Yeah.
Yeah,
Yeah.
okay. Or you consider it like this, right? You have 4x, right? So 4x upon 3 is equal to 2, let's say. So ultimately this 4 will go where? It will go in the denominator, right? Or you can
Yes,
just consider it like this, 4 into x plus 3, because it's in multiplication. You can write it like this also is equal to 2. So now this 4 will come in the denominator. Understood? Yeah.
yes, ma'am.
So this DO will come in the denominator. So only AO upon BO. And this you have CO upon DO. You can do it directly also or as you wish, right? So this is the result. Has everyone written this down?
Yes, ma'am.
Yes, ma'am.
Okay. Next question. Next question is exactly opposite of this question. Now see here, this is question number 10. So this time what is given here? The diagonals of a quadrilateral ABCD intersect each other at point O such that, so the result which we have just shown, it is already given, right? And you have to show this time that ABCD is a trapezium. So it's just the inverse question, right? Okay.
Yes, ma'am.
So let us draw a quadrilateral. So we have to show it's a trapezium. Right now we assume it to be a quadrilateral only, right? So let us draw a figure like any way you can draw it. So I took the smaller side AB. So let's take the same thing, ABCD, right? Okay. And there were diagonals which were intersecting at O. So it is given in the question, the diagonals of a quadrilateral intersect each other at point O. So that's the point O, such that this, and we have to show ABCD is the trapezium. So let us write down what is given here. This time it is given that AO upon BO is equal to CO upon DO. And what you have to prove, that ABCD is a trapezium. So what exactly you have to prove is this, that AB is parallel to DC. This is like what you have to, right? No, don't write implies,
Okay.
or you can say AB parallel to DC you have to prove. Okay. So again, if I want to use BPT or converse of BPT, I need a parallel line at least, right? So again, I'm going to do one construction here. So I'm going to draw, construction, write down. So draw EO parallel to AB. So only one side we use, right? We cannot say that it is by construction that EO is parallel to AB also and DC also. Only one we will write, either AB or either DC. Okay. Let us do the proof. If I now consider the triangle ABC, like where I have done the construction, so let us start from this triangle, right? The green one. Okay. So in triangle ABC, right? Now this is already given to me, that AO upon BO. Where is AO? This side, right? And BO is actually this side. No, sorry. Let us use BPT here. Okay. In triangle ABC, let us use BPT. Why I can use BPT? Because OE is parallel to AB, right? So I can use BPT.
Yeah.
By construction, we have drawn this line OE parallel to AB. So now what does BPT say? It says that AO upon OC is equal to BE upon EC, right?
Yeah.
You can write CO upon AOB or OA upon OC, doesn't matter. The same way you have to take. If you are taking AO here, so you take BE here, right? By BPT. Mana, is this understood? You can call it your result number 1.
Yes, ma'am.
Okay. Now something is given to me. Now what is given? It is given that AO upon BO is equal to CO upon DO, right? Again, I have to do one thing, Martin. See, because here I have AO upon CO, right? So what I'll do is I'll bring this CO here. I'll take this BO here so that it will become the same thing, right? This is given, right? So I can do it AO upon CO is equal to, and I can take BO here upon DO, right?
Yes, ma'am.
Okay, so now you compare, if I call this equation number 2, now you compare 1 and 2. Here also I have AO upon OC, here also I have AO upon OC or CO, right? So again, RHS will be same. So from 1 and 2, fine. So I can say that BE upon EC is equal to BO upon PO, right? Okay. Now, can you just go back to the figure, or let me just draw it again for you here. So this was the figure, basically. A, B, C, D, and this is O, and this is E. So now what I got is, now see here, I have got BE upon EC, right? Is equal to BO upon this side, right? I've got this. So can I say from
Yeah.
converse of BPT that OE is parallel to CD? Right? So
What
it
now?
now see here, I'm getting BE upon EC, right?
Yeah.
Is equal to this side upon this side. So can I just say it means that this line is parallel to this line, right? From converse of
Yeah.
BPT, because I'm
Yeah.
getting the ratio same, right? So therefore, OE is parallel to DC. Understood, everyone?
Yeah.
Yeah,
So
this
since
is
AB is
conver
parallel to A, then
yeah, so it is converse of BPT, right? Okay. So now what we have? Now let us again. Now I have OE parallel to DC, right? Just I mean
this one.
proved above. Okay. And I have OE parallel to AB by construction, right? Right. So therefore I can say again the same theorem we can use. So therefore the line DC is parallel to AB.
So it's at a piece.
Yes. So therefore ABCD is a trapezium. Right. So this exercise is over. 6.2. Only 6.3 is remaining. Let me just check the syllabus again. So in triangle, yeah, 6.4 and 6.5 is deleted from the syllabus. Okay, everyone please note.
Yeah. Okay.
Right, Arsha, Mana, Subhana?
Yes, ma'am.
Okay.
Yes.
So you have to do only these exercises, 6.1, right? 6.2 and 6.3 only. So 6.4 and 6.5, they are deleted. You can please note it down somewhere. Or in terms of theorem, if I say like 6.6 to 6.9. So these theorems are actually deleted. You don't have to do them. Okay. So only up to theorem 6.5 you have to do.
Okay, ma'am.
Theorem 6.1 to 6.5. That will come in exam. This will come in exam. Okay, so let us go to exercise 6.3 now, right? So exercise 6.3 now. So before this, you have to study certain theorems. So the proof of these theorems are not important. Proofs will not be asked in the exam, but you should understand what are the theorems you are going to use here. Okay. So basically here, 6.2 was only based on basic proportionality theorem, right? Let us just go back. So 6.1 exercise was about the conditions of similarity, right?
Yes, ma'am.
Yeah. So there were two conditions. Similarity. So if two figures or two triangles are similar, so we need to show that angles are equal, right? And we have to show that sides are proportional, right? And both of them have to be satisfied together. So the first exercise was based upon this. Then exercise 6.2 was based on basic proportionality theorem, right? And plus its converse. So this we study converse. Now 6.3, you have to study criteria of similarity. Right? So if I just go back to class 9, where we were proving congruency of triangles. So if you remember, there were different criteria like SSS criteria, SAS criteria, right? Do you remember? ASA criteria and like that.
Yeah.
Yeah. So similarly, for similarity also, there are some criteria which we will understand one by one. So you can write 3 criterions for similarity. So there are only 3, right? The first one is AAA, similarity criterion. Right? Or you can just write down one line if you wish. So if two triangles are equiangular, equiangular means all the angles are equal, right? Then they are similar. Okay. Now there's an issue here. Try to understand. For example, I have two triangles, right? And they are similar, let's say. Okay, they're not similar. Okay, they are two triangles. Now I'm saying that angle 1 is equal to angle 2, right? And I'm saying that angle 3 is already equal to angle 4, right? So if I say angle 1 is equal to angle 2 and angle 3 is equal to angle 4, right? So obviously, if, for example, it's not given, but obviously angle 5 is going to be equal to angle 6. Why?
We have to write this.
No, please try to understand, okay? Please try to understand this thing. I told you. Is everybody listening to me? Please unmute your mic.
Yeah, ma'am.
Yes, ma'am.
Okay. So if, for example, angle 5 uh, is equal to angle 6, right? But this thing is not given, right? But ultimately I'll get it. Why? Because I know angle sum property that sum of all the angles of a triangle is 180 degree, right? So if I subtract from 180, like I get 180 minus angle 1 and plus angle 3, right? And for this triangle, I write 180 minus angle 2 plus angle 4. Is this clear? If I want to get angle 6,
Yes, ma'am.
right? So now can I just write 180 minus, now because angle 2 is actually equal to angle 1, right? And plus angle 4 is actually equal to angle 3. So this was, I was finding angle 5 here, okay? And I'm getting the same thing. So that is actually equal to angle 5. So angle 6 is ultimately equal to angle 5. I think there's some confusion. I'll explain it again. Okay, now try to understand it here. I have one triangle, right? And then I have another triangle. Now please try to understand, okay? So this is your angle 1, right? And this is angle 2. This is angle 3 and this is angle 4, right? And so it is given that angle 1 is actually equal to angle 3, this angle, right? And it is given that angle 2 is equal to angle 4, right?
Okay.
Let us try to find the value of this angle 5. So what will be angle 5? So I know that angle 1 plus angle 2 plus angle 5 is equal to 180 degree. This I know.
Yes.
Yes, angle sum property. So from here, angle 5 will be equal to 180 minus angle 1, right? And minus angle 2. I take like other two angles right hand side.
Yeah, okay.
Clear? Okay. Now, in this triangle, I want to find angle 6. So how will I find? Again, angle 3 plus angle 4 plus angle 6 is equal to 180 degree. Understood?
Yeah.
So I want to find angle 6. So angle 6 is 180 minus angle 3 minus angle 4, right?
Yeah.
Okay. Now angle 3 is equal to angle 1. So can I just substitute it? So angle 6 will be 180 minus, in place of angle 3, I can write angle 1, right? And similarly, in place of angle 4, I can write angle 2. Clear? Right?
Yes, ma'am.
I have just replaced. Now, can you see this thing is same as this thing? Yes. What does it imply? It implies that angle 5 is equal to angle 6, isn't it?
Yes, ma'am.
Okay.
Yeah.
So ultimately, I'll get the third angle equal. The meaning is that if two angles are given to be equal, like corresponding angles are equal, the third angle is ultimately going to be equal. Understood? I mean, you don't have to show it. From angle sum property, we know that ultimately it is going to come out to be equal. So basically, this result, which I have written here, A similarity, can also be reduced to A similarity only,
Oh,
right?
yeah.
So that means if in two triangle only two angles are equal, that is angle 1 is equal to angle 3, right? And angle 2 is equal to angle 4. So we don't have to show that angle 5 is equal to angle 6. We already know that it is equal. So we only consider two angles to show that the triangle is similar. Triangles are similar. Is the point clear, everyone?
Yes, ma'am.
Yeah.
Yes, ma'am.
So if we call it corollary, or I mean, there's a term for what we call it. Sorry, corollary. So spelling is so confusing. Corollary, I think we call it this. Corollary means basically this result has been derived from this, right? It is the extension of this result. So basically, either we, if all the three angles are equal, so we write AAA. If any two angles are equal, you don't have to think about the third angle. Just forget about it. Okay. Just take only two angles and show the triangles are similar. Is this okay?
Yes, ma'am.
Okay. So you can again write it here. A similarity, that if two angles of one triangle two angles are respectively equal to two angles of another triangle, then the two triangles are similar. I hope it is understood by everyone. So A similarity or A similarity, it means the same thing, right? Okay, now comes the second similarity criterion, which is called SSS similarity criteria. So if from the name it is clear that if all the corresponding sides are proportional, so this is an important thing. Please write, then I'll explain. If the corresponding sides of two triangles are proportional, then they are similar. Now you can just put this proportional in a box, right? This is important. Now, why is this important? If you just think of congruency of class 9. So we used to show that if you have two triangles, ABC and PQR, right? So if I want to show congruency, now please try to understand the difference between congruency and similarity. Sorry. Right. So I'll say that AB is equal to PQ, right? And I should get BC is equal to QR, and I should get AC is equal to PR. So if the corresponding sides are equal, right? So then we say that triangle ABC is congruent to triangle PQR. Understood? Now let us come to similarity. What is the meaning of SSS here? So I hope you have understood the meaning of SSS in terms of congruency, right?
Yeah.
Yes,
Okay.
ma'am.
1 minute, my system is okay. So that is the meaning of SSS in congruency. Now SSS in similarity, let us try to understand. Again, I have triangle ABC and I can have another triangle PQR. So what is the meaning of proportional? I should get AB upon PQ, right? Not equal to PQ. I should get AB upon PQ is equal to BC upon QR, right? This side upon this side. And I should get AC upon PR. So all these ratio have to be equal. So the sides don't have to be equal, but the ratio of the sides have to be equal. Or we call it that the sides are proportional. So this is the meaning of SSS in terms of similarity. Understood? You can note it down in your copy. Just write both, congruency also and similarity. So this will make things clear in your mind. In case of congruency, what is the meaning of SSS? And what is the meaning of SSS in case of similarity? So this is the meaning here.
Oh, so directly equal is the congruence.
Yeah, so congruency means exactly the sides should be equal, right? AB equal to PQ and BC equal to QR, and obviously AC is equal to PR. So all the three sides have to be equal, then only it is called SSS criteria. But here, if the sides are proportional, then it is called SSS criteria. Clear?
Yeah.
Okay, please note it down. So here I'm ending the class. There's one more criteria. So I'll just explain that in the next class. And then we will do exercise 6.3, right?
Okay, ma'am.
Actually, I want to take a test also. Before this, we have done which chapter?
Probability, ma'am.
Probability, okay. Can I take a test of probability in the
Yes,
next class?
Yeah, okay, ma'am.
Okay, so everybody please prepare probability for the next class. I'm writing here, test. Today is 27, so it will be 29/09/22 probability. Fine, Abdullah?